Hi, Grandma. So I understand you had some questions about how genetics contribute to obesity and what the policy implications are of that. So, to start off, there have been studies that have found significant evidence that genes do, in fact, contribute to obesity. One of the more compelling studies was one done by Stunkard et al. In 1990. They did a very interesting study involving twins and looking at their BMI to see if there was any correlation. And what was very interesting about the study was that the twins that they studied had actually been separated at birth. Separated when they were around 3 years old. So they were raised in different families and in different environments, and they measured if there was any correlation between their BMIs, their body mass index, and they measured that correlation using the Pearson's correlation coefficient, with -1 being no correlation whatsoever and a score of +1 being that there is a correlation there. And interestingly, they found that for males it was 0.7 and for females it was 0.66. So there was a very strong indication there that genetics had played a significant role in determining their weight, specifically their BMI. Other studies have also found that twins tend to lose weight in the same places, also indicating a strong genetic influence there in terms of fat and obesity. Other scientists have done studies as well where they have found that individuals with high metabolic rates can consume diets high in fat without gaining weight, and also that individuals who are susceptible to weight gain have an impaired ability to increase fat oxidation, and fat oxidation increases fat burn. So those two factors, the high metabolic rate and your ability to oxidize fat, are also controlled by genetic factors. And interestingly, in 2007, scientists discovered the fat mass and obesity gene, which increases your likelihood of to be obese by 67%. And it was specifically associated with high fat intake and impaired satiety responsiveness in children. So usually when you're full, your brain sends a signal to you to stop eating because you're already full. But this gene had a mutation that somehow distorted your ability to process that signal that you're already full, in children specifically. So in terms of genes, scientists have found 600 genes, markers, and chromosomal regions associated with the expression of obesity phenotypes in humans. Of these, 10 cause obesity due to mutations, but these mutations are usually pretty rare, with the exception of one gene, which is the melanocortin-4 receptor gene. 35 different mutations have been found with this gene, and amongst obese individuals, 1 in 17 have this defect. So how can these mutated genes cause obesity? Well, there's one example would be Cushing syndrome, which results when a gene mutation causes your adrenal gland to excrete excessive amounts of cortisol. Now, cortisol is a hormone that retains fat. So people specifically with Cushing syndrome tend to have accumulate fat in their upper body. So they have rounded faces, accumulation around their neck area, in their abdomen, but yet they have thin arms and legs. So the majority of these genes, let me rephrase that. A few of these genes can cause obesity no matter what environment you live in, but the majority of these genes excrete relatively small effects, and it's when they act in combination with each other in permissive environments that can lead to obesity. So what do I mean by permissive environments? So I'm referring to environments where people don't have access to healthy foods or opportunities to engage in physical activity. So in terms of policy implications, you will look at policies that increase people's access to healthy foods. So you might look at policies that incentivize farmers to set up farmers markets. Also, maybe look at healthy food retail, where you require restaurants or food establishments to provide the number of calories and their food items so that people can make healthy food decisions. But you can also look at policies that look at the physical environment and the built environment. So you look at policies that make sure that communities are walkable. And by that I mean that there are safe sidewalks, there's designated bike lanes, safe parks, lighting so that people can go walk in the evenings and the early morning hours. So you look at policies that increase access to physical activity opportunities. And these policies are aimed at influencing the environment to mitigate the effects of these genes that you might be carrying. So it doesn't necessarily mean that you would be obese if you carry these genes, but if that combined with environmental factors and your diet, your level of physical activity can increase your chances of being obese and result in obesity because you have these genes that would make you susceptible to weight gain or not be able to burn fat fast enough. So I hope this gives you a brief idea of how genetics contributes to obesity